Hello, this is Mr. Wynn, and today's video will be solving systems of inequalities by graphing. So this lesson is all about graphing and shading. If you're good at 2-7, it should be very easy on 2-8. So we're going to graph two different lines, do the shading, and if there's overlap, that's going to be the answer. That's called the feasible region. So the steps are graph each one separately and shade like normal, then see if there's any overlap. If there is, that's the answer. If there's none, then no solution. So here's the first one. Y'all know how to sketch these. We know that this first one is linear. We know it is down 4. We know it is taller. And we know it is a dashed line. So I'm going to sketch that. I'm going to start at down 4, somewhere over here. Taller, regular diagonal line. So there's my line. I forgot shading. If you forgot, you do test points. You plug in 0, 0. So 0 for y, 0 for x. 0 should be greater than 0 minus 4. 0 is greater than -4. Is 0 bigger than a negative number? That is true. So I shade the side with 0, 0. That means this time it's to the left. So I'm going to draw it like this. Alright, that's my first one. Now I do the second one. The second line is also linear. It is up 3. It is wider or flatter. And it is flipped upside down because of that negative sign. And it is solid. So knowing that, I'm going to go from the origin, go up 3, somewhere over here. Instead of making a regular diagonal line, I'm going to flip upside down. I'm going to make it wider and solid. So here's that line. All right. Now if you're out shading, again if you forgot, you just do a test point. You plug in 0, 0. So 0 there, 0 here, because anytime 0, 0. Is 0 less than or equal to 3? That is true. So I shade the side with 0, 0. In this case for the red line, it's underneath the red line. Alright, I shaded both. I'll try to find my answer. As you can see, this area right here is both green and red. So here's that area. That is what they call the feasible region. So that top one with just above the X was just green, that's not good enough. The bottom of the X is just red, that's not good enough. Right of the X is nothing. Left of the X, that blue area, that's the answer. That's the overlap. Now we try it again. Same idea, graph each. Y is greater than or equal to x plus 5. Well, that's linear. That is up 5. That's a solid line. So I start, instead of the origin, I go up 5, about right here, and draw a normal x, regular diagonal, not taller, not wider. There you go. I plug in 0, 0 to see where I shade. Well, 0 for y, 0 for x. 0 is greater than or equal to 5. That is false. So I do not shade the side with 0, 0. I shade the side without 0, 0. This time it's going to be the left. So here's that area. Alright, I'll try the bottom one. Y is less than x minus 4. Again, it's linear. It is down 4. And that's it. So, oh, it's also dashed or dotted. So I go down 4, somewhere around here. Regular diagonal, it's not taller or wider. And it's dashed, so let me erase part of these. Alright, there you go. And now if you're out shading, I plug in 0, 0. 0 for x, 0 for y. 0 less than -4. Is 0 smaller than -4? That is false. So I don't shade the side with 0, 0. I shade the side without it. So this time it's the right of this red line. Alright, now look at my picture. Is there any overlap? No, they both go different directions. This has no solution. That's my answer. Alright, now solve the system inequalities and find the vertices of that feasible region. So I'm going to graph each one. Y'all know get y by itself, so I'm going to divide everything by 5. So y less than or equal to 2 over 5x plus 9 over 5. I'm going to graph that. We know that is linear up 9 over 5, which is just about 1.8. It is wider or flatter, and it is solid. So up a little bit, 9 over 5, let's say it's right here. Wider, it's not flipped. It's going to look like this. And I'm going to say this is 9 over 5. There. Alright, I figure out where to shade by plugging zeros in. Well, if I put in 0 for left side turns to 0, 2 times x is 0, that's 9. Is 0 smaller than 9? That's true. I shade beneath. Alright, I did the second one. Y is already by itself, so go straight to it. It is linear. It is up 6. It is flipped upside down. And it's solid. So I start up 6, somewhere up here. It's flipped upside down. It's not wider or taller. It's just normal. So I just draw it. This off my graph. That's okay. And now I trigger out shading. I plug in 0, 0. Well, the left side turns to 0. The right side is a 6. Is 0 smaller than 6? That is true. I shade the side with 0, 0. This case is over here. So I have some overlap already, which is good. Now the last one, I get y by itself, I'll divide everything by 9. So y is greater than or equal to negative 2 over 9x plus 5 over 9. Again, I know this is linear. I know it is up 5 over 9, not even 1. I know it is wider. I know it's flipped upside down. And it is solid. So I'm going to go up 5 over 9, about right here. It's a regular diagonal line. It's flipped upside down, and it's wider, so I'm going to do like this. And I figure out where to shade it. So I plug in 0, 0. Well, this left side turns to 0. The right side, negative 2 times 0, 0 plus 5 is this. It says 0 is greater than or equal to 5. That is false. So I do not shade the side with 0. I shade the other side. So this is above this red line. Alright, that did not work too well. That's fine. Alright, so as you can see here, I'm going to use a special color. What color do I have? Let's do this. As you can see, the red, blue, and green is this area right here. I'm going to outline it in black for y'all. It's this little triangle. Everything inside there. That's where it overlaps. Alright. Now, it also says, so that's my answer, that's the feasible region. But it says, find me all the point of the vertices. They want to find me this point right here, whatever number that is. This point, whatever x, y, that is. And this, whatever x, y, that is. So to find that, you're going to have to solve them 2 at a time. So from last section, 3-2. So this first one, I have 5y basically equals, because that's just for shading, 2x plus 9. In the second one, I have y equals negative x plus 6. But if you notice here, I can do for these first 2 problems, I'm going to do substitution. If I plug this y for y right here, I get 5 times negative x plus 6 equals 2x plus 9. I'm going to distribute, so negative 5x plus 30 equals 2x plus 9. I'm going to add 5x to both sides. 30 equals 7x plus 9. I'm going to subtract 9 both sides. 21 equals 7x. And I'm going to divide by 7. X equals 3. So I know x equals 3 the first one. I'm going to plug into either one. I'm going to use this one that has y equals by itself. So that is y equals negative 3 plus 6. Well, negative 3 plus 6 is positive 3. It's my y. So for the first two, I know they intersect at 3, 3. I'm going to do the same thing for the second two. So basically, I have, again, my second equation is y equals negative x plus 6. And this other equation, I have 9y equals negative 2x plus 5. I'm going to do substitution. I'm going to plug this y for y right there. I get 9 parentheses negative x plus 6 equals negative 2x plus 5. Distribute. Negative 9x plus 54 is negative 2x plus 5. Add 9x to both sides. 54 equals 7x plus 5. Subtract 5 both sides. 49 equals 7x divided by 7. X equals 7. There's my x. Got to find my y. I'll plug into this equation right here. So y equals negative 7 plus 6. Well, that's negative 1. So I know 2 points. And we're not done. We're going to do one more. I've used the first and third equations, but you'll see it's a lot of plugging in, a lot of steps. For my 2 points, I know one of the answers is, for the top one, was 3, 3. For the bottom one, I have 7, negative 1. So instead of doing it again, which you're supposed to do, I'm going to say for this class, since it takes so long, I'm going to use a calculator. So we're going to go to the good friend Desmos. As you can see, I did it. There's our triangle. You can see that middle triangle. If I click where the intersection is, you'll see it says 3, 3. Well, that's the point we found. We also found 7, negative 1. So I go over here, click this point. That is 7, negative 1. And the last one we did not find will be right here. That is negative 2, 1. So it's a lot of work. I didn't even finish all the way. But I'll let y'all use Desmos, or I'll graph it for y'all, where I just click on the intersections. Just be able to sketch it and see if it has a feasible region. You should be able to draw a line and shade the correct way. All right, here's your practice problem. Try it. It has absolute value, but you should have that green shaded area. All right, again, this is Mr. Wynn. Thanks for watching. See you in class.